Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and welcome back to Making Games. So today, I am going to continue trying to make up for lost time with the 3D wizard game project thing that I've been working on. I spent a lot of time not doing that in the last few weeks when I was working on 3D collisions, and now that that's finished, I would like to get back on track. And today I'm going to be just doing a few housekeeping things in this project. Last time, I made use of the sphere displacement code to solve a few different problems at the same time in the 3D collision system with regards to things just feeling a little sticky or not precise. And today I'm going to be basically just taking care of some things that have been sitting on this board for ages and I've been putting off dealing with. First, if I can find it, there has been a YouTube comment that someone left on one of the previous videos, which is a little long. I'm not going to read the whole thing out loud. You can read it on the screen, and it mostly boils down to the behavior of collisions when you're in proximity to moving objects. There's a few parts to this, some things that I wasn't really thinking of. Basically, when the player is in close proximity to moving objects, you're, well, it'll be helpful if you try to anticipate the position of the object in the next frame, instead of just displacing yourself from where you are now. Given that I don't think the system feels terrible in that regard, I'm not sure if I really want to spend any more time on this than I already have. If I was working on this game 40 hours a week for a whole year, I obviously would devote a little more time to that, but instead I'm giving this game more like 45 minutes a week. And unless the code is just going to completely break, I think I should probably start working on some of the other parts of the game. There is one bit of this that sticks out to me, which is that if you jump and your head hits an object that's moving up, your Z speed shouldn't automatically be set to 0. It should be set to the speed of whatever's above you. And that's something that I might think about doing if it feels like when I jump underneath a moving platform that like my head gets stuck to it, or that my head, or maybe I should say if it feels like my head bounces off of it harder than it should. That's something that I could see being a little bit more noticeable, and I could see me wanting to deal with it at some point down the line. But at least for what I work on recording, I think I'll leave it where it is right now. Of course, in the future, if I want to come back to working on this and tidy it up, I have a feeling I'll be referring back to this YouTube comment. And of course, if any of you all are interested in working on a 3D platformer of this sort, you might find some value in this YouTube comment. One way or the other, thank you to Mr. Ray U. Johnson for taking the time to write that out. So there's another issue that I did notice pretty much as soon as I stopped recording. The last video, I think I actually may have come across it on the recording itself, and I just forgot to, well, notice it really. And that is that if you jump when you're next to an object like this, you will get stuck. You'll get stuck on the wall. If you fall next to a wall, you will get stuck on the wall, and that boils down to the size of the like the grounded platform that's beneath the player's feet being a little bit wider than the actual radius of the player in places, and causing the game to detect that you are that your grounded platform is in contact with something when it shouldn't be. I think the easiest way all around for me to deal with that would be for me to go into the collision shape that defines the player, for me to go and, let's say, shrink the grounded platform a little bit. Right now, it looks like it's got a radius of 30... I'm pretty sure it had a side length of 32 in the live version of the game, and it says 30 right now because I was experimenting with it on my own. I'm just going to shrink that down to a side length of 24. The greatest extent, so the corner of the grounded platform just needs to be some length that is smaller than the radius of the player. So if the half side length is 12 times the square root of 2, because it's alright, so that'll be basically the radius of this the square. So the distance between the center and the corner is 16.92. If I want to be really rigorous, I might want to shrink that down a little bit more, just enough that that hypotenuse of that triangle is less than 16. But I think Yeah, I might as well do it right, because I don't want to have to run into this again if you approach a wall from exactly a corner. So 11 times square root of 2-ish is 15 and a half, so that'll be small enough. So let me re-export these. You might notice, by the way, that on my own time I did add a few more shapes. There's this light post, which is just I mean, it doesn't emit light or anything, but it's just the model for a light post, and it's got some collision information on it. I've also added a top platform, so a climbable platform to the bridge shape, so that the player can climb up that. That's one of those things that I thought I did already, but clearly I didn't. For the sake of, you know, making the level geometry a little bit interesting. Oh, that's right. I also renamed block underscore singular to just block. All right. Let's use the correct name there. But yeah, climbing on level geometry like that is something that the player would probably expect to be able to do. So now, if I jump, and that corner of the slope is sticking out a little weirdly, so I'm gonna try over here instead. If I jump, I will no longer be caught on the side of the wall, which is good. If I jump under here, we're fine. If I walk up the slope, I can still walk up the slope, and I can initiate the climbing sequence when we reach the top of that bridge shape, because you know, it's climbable now. And also, if I climb up here and like fall, and ooh, okay, that's another bug. I was falling, I entered the climbing state, and now I appear stuck in the climbing state. That's yeah, if I all right, let's exit that. I entered the climbing state and I never left, so I'm gonna wanna track down that little bit of logic that causes that to happen. So that's that little bug that I wanted to address. There's also the matter of, you may have noticed that some of these cards in the basic gameplay handle already marked as complete. I recorded this video already, and I decided I didn't like how it came out. It was very meandering, and it wasted a lot of time on things that should have been pretty simple, and I decided to just do it again. But get rid of the magic numbers and player movement. There's not many of them left, but like in the last couple of videos, I've been making an effort to not have that many magic numbers if I can get away with it. But there are a few left, and I will try to track them down, and also delta time, comma, or something. I've been talking about doing that for a while. I haven't really paid it much mind, and I think I'm finally going to actually deal with that. So, I believe the only real magic number that remains in this entire game is the radius of the player, so the size of the player. There's a couple hard-coded 16s here, there, and everywhere, mostly with like regarding player movement and that sort of thing. And I'm just going to assign a radius value in the NPC create event, and anywhere where I find a free-floating 16, I will replace it. Not all of it, if I search for just 16 in this code, not all of them are actually going to be related to the size of the player, but in things like obj, NPC, and step, we're going to have a player radius and the potential movement. We're going to be subtracting it once we've figured out our potential movement. This would be a lot easier if, like, I just said the player's position was in the middle of the sphere collider and not at the bottom of the sphere collider. Are there any others? So that's a camera thing, 16 by 9, 16 by 9 S part, input, some shader stuff. I think that might actually be it. So this is like a re-recording branch. This is gonna get discarded after this video is published anyway. Do I really want to commit these changes? I'm gonna be a bad influence. Anyway, that's going to be the magic numbers and player movement. The matter of delta time, comma, or something is going to be a little bit more involved, so there's a couple places in the various player events and that sort of thing, especially where movement is concerned, where we're dealing in terms of units per frame instead of units per second. And even if frame time independence wasn't the thing that I cared about, frame rate independence, I still have an easier time thinking about motion and space in terms of units per second than I do in terms of units per step. Because saying that you're going to move at a speed of, like, say, 4 feels a little bit arbitrary, whereas saying that you're going to move at a speed of 240 units per second, where, what's 240 units? If my world size is 32, so 7.5 meters per second. Like, that's something that I can wrap my head around. Let's start by, do I have a macros? I have a macros file. So instead of using GameMaker's delta time built in, which is the number of microseconds since the last frame was processed, and that accounts for things like lag and that sort of thing. I'm not going to worry about lag. All I'm going to worry about is going to be the actual target frame rate. Get speed, game speed, microseconds. So I'm going to want that in terms of seconds. So microseconds divided by a million is seconds. The game's target frame rate might be 60. So get speed microseconds is going to be 16,666. If I divide that by a million, that's going to be 0.016, which is the number of seconds per frame that you have allocated if you want to meet that target frame rate. I'm going to stick that in a macro, call it DT, make sure the parentheses are in the right place, and call it a day. So I'm going to take all my velocities that are in terms of units per second and multiply it by DT, and that'll get units per frame. If you are running your game at 60 or 40 or 30 or something else frames per second, then the rate of motion will compensate for that. If your game lags, if your game's target frame rate is 60 but you're only getting like 30, then your game is going to feel like it's going to slow down, and I'm not going to open that can of worms. Pretty sure I did the same thing in Bombardier and Bogey as Hell. I think my energy would be better served trying to optimize other parts of the game than trying to achieve true frame time independence, with all the knock-on problems that might entail. You are free to fight about that in the comments. Also, and this wouldn't ordinarily be a concern, but I believe I mentioned once or twice that one of the potential spells that I had in mind for this game was a slow time spell, which would slow down the passage of time for basically everything that isn't the player. For that specific purpose, it is occasionally useful to have a second delta time value, one for the player and one for everything that isn't the player, and the delta time for everything that isn't the player could be multiplied by an additional time scale or something of that nature. But I think I will cross that bridge when I get there. So let's start with something easy. So do I have a moving object? I have a moving object somewhere in here. So the moving object, right now, it's going to move up and down on the y-axis, and it's going to be moving at a speed of 0.25. When it's going up, it's going to be moving at a speed of negative 0.25. When it's going down, that's going to alternate every 10 seconds, every 5 seconds. And that, of course, is fairly easy to translate into a units per second. So 0.25 times 60 is going to be 15. And on the way down, it's going to be negative 15. That is going to be our, like, I guess I'll call it our base movement. And when we actually update our position, I will take the base motion, multiply it by the delta time scale. And now when I run the game, it should look exactly as it did before. No funny business going on. All right, we're still moving at the same speed as we were. And indeed, when I jump, and when the thing is going up in the air, it yeah, my head kind of sticks instead of matching the speed of the object that's ascending. Honestly, I might just deal with that off camera. That'll be essentially the same thing as like the grounded check, but instead of checking for something that's below the player's feet, checking if there's anything above the player's head, and like setting your vertical speed to match that thing's vertical speed. Anyway, I don't think there's any other moving objects in the game currently besides the player, so this shouldn't be too painful to implement. Can I close that camera code file right now? Because I don't really need it anymore. And where else do we have velocities? So the run speed, the walk speed, so 5 times 60 is going to be 300, 3 times 60 is going to be 180. That's going to be our base speed when we're running or walking. And when we figure out our like instantaneous speed based on whether the run button is pressed or not, we can take the run speed and the walk speed, wrap that expression in parentheses, multiply it by the time scale. Same thing for the jump speed over here. What was that? 4 times 60 is going to be, I can math, 240. Set our y speed to 240 times the time scale. I am treating the player's XYZ speed like the instantaneous speed, like the speed that we're moving in that frame, which is a little bit different from what I just did a minute ago for the moving object. And basically the reason for that, and I'm not 100% sure if this is the best way to go about it, to be honest, but the reason that I did that is because I expect this value to be set in every frame, like to have your movement speed calculated every frame, instead of just firing it and forgetting it like we are with this the blocks motion. So I hope that's not something I come to regret. Where else do I want to change? There's the camera speed. That's another one. I'm also noticing that I mentioned that my convention is for configuration values like this to make them static variables, not because I need them necessarily to be static variables, but just because it like sends a message to my future self when I'm reading the code that these are supposed to be like configuration values. And I forgot to do that here apparently. Anyway, so camera speed is currently 10. If I want that to be per second, let's make that 600. That feels a little fast. That value might be worthy of fine-tuning later. And when we zoom in, zoom out the camera, we can multiply that base camera speed by the time step. There's got to be more, right? All these, when we're like fetching the collision shapes with particular names from, the list of collision shapes, that's another thing that I had in mind to fix, to write a little nicer code for. And I'll do that after I do this. Let's see. So climbing. So I'm scrolling up and we're getting into the actual state system now. So the speed at which you advance forward when you climb is 1. So let's make that 60. Multiply any uses of that by the time scale. Okay, so the climb speed is also basically same thing. The rate at which you ascend. Let's multiply that by the time scale. Moving up, when you obey gravity, this might be a little bit harder. Let me see. So if I were to like jump, and this is going to be a super informal test, but I get about a little bit above the middle of that top block over there, and 1 Mississippi. I'm going to say it takes about a second for me to come back to the ground. Acceleration and delta time is a little bit, shall we say, not a lot of fun. Firstly, I really should just leave the Windows calculator open, but what is 0.15 times 60? That is going to be 9. So I'm going to set gravity to 9, which coincidentally happens to be more or less the value of gravity in real life. Negative 9.8 meters per second squared. Doing accelerations and higher derivatives in general with delta time kind of becomes a little bit messy, and I can never remember what like the exact correct way to do acceleration with delta time is, or things like odds, like if you have an odds per frame / odds per second with delta time. And I've looked at the math behind that like 10 times, and honestly I could probably derive it myself or integrate it, as the case may be, if I stop to think about it for 2 seconds. But for the time being, let us let us just see if this is a close enough approximation. And yeah, so we get about halfway up the top box, and it takes about a second to land. If I were to change my game speed to 30 and apply that, how different would that be? It won't be exactly the same. It might be close enough that it's like tolerable. Obviously, I don't want to just leave it tolerable. Okay, never mind. That's a little bit farther off the mark than I was expecting it to be.
Hey.
Yeah, I can't remember how to deal with rates of change like that in delta time. I want to say it's like 1/2 AT squared, which is something that should look very familiar if you've ever had to solve like kinematics equations in physics, or if you've ever taken pre-calculus or anything like that. And this is really going to bother me if I don't do it, but let me just see if I can find that really convenient equation real quick. I know that like Juju Adams has told me about it like 10 times, and I keep forgetting it every time. Alright, I literally only realized that I'm on the GameMaker subreddit when I looked at the username here and said, hey, Flying Saucer Invasion, I know that guy. So, that's awkward. So aside from that, the other, like, math repository that I find myself on somewhat frequently whenever I'm trying to do this is the Juju talk on Hyperlight Drifter. And assuming that he knows what he's talking about, and I find that most of the time Juju does, velocity equals the timescale times acceleration. That's straightforward enough, and also we're going to want to add not only timescale times velocity, but also 1/2 AT squared. As I mentioned, I feel like this is a rabbit hole that's going to involve me spending a lot of time fiddling around with numbers, and I should probably just acknowledge this and then off-screen it instead of trying to spend the next who knows how long on this. So I think instead I'm gonna leave that there. Did I set the game speed back to 60? I did. Hopefully this won't be too painful. And are there any other places in this code where movement is handled that I'm gonna want to delta timeize? I think that's it. Let us let's make consistent use of my my conventions here. All right. So I also mentioned that it would be a little bit nice if I could take code like this, where I'm just doing a glorified array search, array find index on my list of collision shapes, and it's a lot of code that's being written out every single time I need to do something like this. And it would be nice if I could just take this and turn it into a single function call, something like array search by name. If we were to take our player data collision shapes and just pass in the name, camera target, something like that. So I'm gonna do exactly that. That's gonna... Our camera target is just the position, so we can continue saying dot position after that. I'm going to go into, I've got like a common code library here, right? And I can write my array search by name. And we're assuming that an object with a .name that's specified exists here, which I probably shouldn't do. So I'll say var index is going to be array find index of the array search. And instead of hard coding pound camera target, we can pass it in a name as a parameter. Unfortunately, GameMaker does not support closures, to the dismay of some, although perhaps not me. So I'm going to have to do this a little bit of a long way. And wrap this in a method. Just like wrap that one single value in an object and search for that. And then if index equals -1, which is to say if the name wasn't found, we can return undefined. Otherwise, return array, return the value at array index. Was like this shorthand for creating a struct with a variable, was that implemented in 2023.6, or is that something that's just in beta now? I'll find out by running the code and seeing if it crashes or not. And if it crashes, that means that I can't do it. If it doesn't crash, that means I can. Let's finish implementing this for the other places where this is needed. So that's going to be the climb detection shape. Much nicer line of code than we had before. And also, I think there's a third one down here, the grounded. The grounded shape to figure out if you're on the ground. And I think there's a couple other places where these are used, although it looks like that is being handled differently. So I think I will be able to not have to worry about that right now. Okay. So if I run the game now, we should have our climb target and our camera target and everything like that. All right. And that's just a bit of a nicer line of code. So we can still do all the things we did before. We can check if we're grounded or not, you know, the whole deal. But it's one relatively short line of code instead of 3 fairly long and stupid lines of code. So that's nice. So what have we done today? I have done, I got way too many. Like, some people have a problem with browser tabs. I have a problem with browser windows. I think I can close both of those. But yeah, delta time comma or something is done. The magic numbers are done. The bug with the size of the grounded platform is done. This array search by name is done, which is just a little mild convenience thing. And is there anything else? I think that was all I wanted to do in this video. Once again, I'll properly try to hash this out off camera. Oh, there's also that bug where I tried to, like, climb and fall off something at the same time and it got stuck. I probably should investigate that now, shouldn't I? We can start by debugging some values. You know what? GameMaker gives us easier ways to print out messages now. All right, $5 says the solution is going to be just setting the Y speed to 0, ensuring the Y speed is set to 0 when you're in the climbing state. But first we'll see if before I do that, I just want to see what these values are. So I'm going to have to, help, climb up here, as one does, and then fall off real quick. All right, it looks like, yeah, it's not unsetting my Y speed when I'm in the climbing state, and I have a feeling that, because it wasn't changing, it wasn't being updated due to gravity when I was falling, I have a feeling all I'm going to need to do is make sure that my vertical speed is... Alright, there we go. So we basically fall off and then grab a hold real quick before falling. Alright, that's good. I'm glad it was that simple. So, that is going to do it for me for today. 2 cards that I'm not going to check off. I looked at fake shadows and I thought I had a simple way to do that. And conceptually it works, but unfortunately I'd forgotten that I insisted on doing the deferred renderer thing. Largely just because I can and because I want to. There's not really any pixel pushing advantage in this particular game. I'm not making a huge open world that would really benefit from that. But in in the deferred pass, all of our coordinates are in view space, not in world space, and that does indeed complicate what I wanted to do for fake shadows a little bit. So I will sleep on that. I will either work out the math to make that work in view space, or I will... Honestly, it's not impossible that I'll just ditch the deferred renderer and go with the forward renderer, but I do want to do the deferred renderer just because I can. But if it proves to be more of a hindrance than a help, I might go back. And the entity render loop card, which I realized is something that would make a little bit more sense to check off after I actually have more entities in the world. You know, different things that are actually being rendered. So I'll hold off on that until after I've actually got some of those. And lastly, this is going to be the subject for the next video, which I'm going to treat like the basically the wrap-up, the conclusion for the basic gameplay era of this project, the Unity import. I've been experimenting with that, doing some tests. I've got some code that should work without too much issue. We'll, of course, be fine-tuning that as we go along. I'm not going to be writing that on video. I mentioned at the beginning that I don't think this is going to be breaking the Unity terms of service or anything like that, but just to err on the side of caution, I will shy away from publishing the code I've written to do that, at least on the Unity side. So next video, I'm going to be discussing that. I'm going to be building some test levels in Unity. We're going to be able to like platform around a little bit on a level that I built in Unity, and it'll be a fun time. And then it'll be off to Magic gameplay stuff, which is also going to be a fun time. So, my name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down in the video description. If you want to mess around with any of the supplemental projects that I've been using to put this together, such as Penguin, my 3D model converter / general helpful bit of software, or the 3D collision system, I will have links to that down in the video description as well. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. I hope you all find this entertaining, and I will see you all later. Special thanks to Army Armbuster, DJ Gibbles, Edward Holt, GameMaker, Manta Ray, Syndra Larson, Squarecrow, Vitro V, and Zenjament for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.